So as we had our previous calculations, we managed to consider formulas and other examples that can be done, that can be made in our three-phase induction motor, the calculations that can be made. So we are going to have a continuation still on our three-phase induction motors, but in this case, focusing particularly on the calculation of the maximum torque. The torque can be determined from these formulas as we had, but when it is for a maximum torque, we are not going to consider this part. There are conditions that we need for us to determine the torque when it is what? Maximum. When it is what? Maximum. So what is it that exactly going to affect our maximum torque? So the conditions are that, remember when we had the calculations of the rotor values, you were saying that the rotor value actually is the same as what? As the resistance value that we have at standstill. But in this case, guys, we will be surprised that this value at standstill can actually be determined from the reactance. That's a condition for us to obtain a maximum torque. So the condition will be for us to obtain this maximum torque. The resistance for standstill, that is the standstill rotor resistance per phase, must be equal to the maximum slip times the reactance that we have at standstill, the standstill rotor reactance, remember. So this is a condition that must be followed anytime you are at what? Maximum torque. As long they want you to calculate the maximum torque, you have to consider this. So that is our condition. Remember, there we've got what? Our standstill. So we're still at standstill. Remember the denotation of 2. I said these are what? Standstill. So these are your standstill rotor. That's rotor resistance per phase. All right. We have this slip. When we say the maximum, that is the one that is at maximum torque. So that is the slip that produces maximum torque. So this one is simply the slip that produces maximum torque. All right. And our reactance at standstill, remember the denotation of 2. So that's our reactance at standstill. So that's our standstill rotor reactance. So remember these, which is taken per what? Per phase. So with this, we can find whatever that you're given, depending with the information. You can find whatever according to this information that we have. We can find any part. So what happens that at maximum torque, we must have the slip that produces that maximum torque. And in terms of the speed of the motor, we are supposed to have the maximum speed that is affected there. So we are going to notice that maximum torque occurs at what? So the maximum torque, which is T max. Just gonna write this in short as what? T max. So it occurs, all right, occurs at the speed. It has to be maximum of the motor, speed, and also the slip. And what? And maximum slip. And the slip has to be maximum. So they are at maximum conditions, like we are calculating maximum torque. So we consider that at maximum, our slip and what? Our speed, the rotor speed. just like that. So with these conditions, therefore, how do we calculate that? It follows that T1, the formula that is used for maximum torque, the formula for maximum torque is taken from T1. So it follows that T1, which is the torque that is at any slip except for when it is maximum. The slip there that you're talking about is at any point. I mean, the torque that you're talking about can be determined at any slip that you're given, but not at maximum slip. Because at maximum slip, we are talking about what? Maximum torque there. So please do not confuse on that one. So that's gonna use this formula 2S1. So the slip there, this one, it goes together with what? The slip goes together with this torque that you're given there. All right, remember our R there. So we're gonna have RP2 squared over what? Over that's RP2 again squared plus S1 slip times XP2. With this one, remember what are we obtaining here? What are we obtaining actually? What are we obtaining? When we multiply slip and what? Reactance, we are finding the rotor. This is our rotor value, all right? So that's our rotor value that we are simply having, all right? But we are supposed to square the whole of this part. So that's squared. This whole part is affected by the maximum slip. So you're supposed to multiply this to the maximum slip. Just like that. So that is what we are going to have as our formula. So this formula, it can be manipulated to find whatever that you want there. It can be manipulated times our Tmax, which is, so T1 is equal to this whole part times what? Times Tmax. It can be manipulated to find whatever that you want. Meaning to say, if you want to find Tmax, maybe we are not given, and we are given the torque that is at this slip, we simply have to divide by this whole bracket to find what? Our Tmax. So that is the condition. So what is happening? T1 and what? S1. They go hand in hand. At what? At S1. So Tmax goes hand in hand at what? Maximum slip. That is the condition. So the S1 is the slip that produces this torque. The S max is the slip that produces this maximum torque, according to the information, how you take your information into consideration. So with this and the other information that we had before, we are simply going to attempt our questions. We do not have much about the maximum torque. So let's consider this question that we are given. That is a 4-pole, 50 hertz, 3-phase induction motor. We are working with what? A 3-phase induction motor in this case, all right? So let's see what happened on our 3-phase induction motor. According to our information, this is what we are given, a 4-pole. That's the number of pair poles, 4/2, which is what? 2 pairs. So meaning to say, in this case, we've got what? We've got 2 pairs. 50 hertz as our frequency. All right. Develops a maximum torque. Take note, we are given the maximum torque, which is what? 220. Remember, torque is measured in what? Newton meters. At a speed of, it is producing this at this speed, at that speed. What does it mean? Remember where the maximum torque happens. It happens, or it occurs at Nmax and what? The slip that occurs there. So that's the torque that is corresponding. I mean, the speed that is corresponding to this torque that you're given at that maximum value. This is our maximum speed, which is 1,375. That's at what? At maximum speed of what? 1,375 revs per minute. So actually, someone might be asking, why is it that we need maximum values? Because of this here, we can conclude that remember how you calculate your per unit slip. Remember, per unit slip, you're calculating per unit slip as what? NS minus N over NS. So when it is maximum now, maximum, this one is going to be what? Maximum. All right, this is NS. Yes, sorry, this one. So this will be maximum for the rotor, the part of the actual speed of the rotor. It's the one that is at what? At maximum torque. So it's going to affect your formulas. That's why you need to consider that when you are taking your values. All right. Then the rotor resistance per phase, we are given the rotor resistance per phase as we are dealing with our rotor values. We're going to take that as a standstill value. All right. That is 0, 0.2, 0, 0.25, 0, 0.25. Remember our condition of what? The resistance, that it is not affected by the slip. So that remains as our what? As our standstill value. We just take that one as it is. So this is our condition now. Let's answer our question. The question was calculate. See here, calculate. A, the standstill rotor reactance per phase. The standstill at standstill, the denotation is what? 2. So they want you to calculate, remember it's a phase per phase. They want you to calculate the reactance, this one, at standstill. How are we going to have that value? Standstill value. How are we going to have this? So guys, as we are to consider all the formulas that we had, we are not going to focus on that. We are going to focus on the formulas for maximum torque. Why? Because we are given these conditions, whatever that we are having there, had or gave us a maximum torque. So meaning to say, as we consider this, we are supposed to ask ourselves, is there a relationship which is at maximum torque that years what? That reactance. And if you consider on those conditions, the first, this condition, it has what we need. The standstill rotor reactance per phase, it is there. So we're simply going to make that the subject of the formula. All right? We're simply going to make, because we are saying RP2 is equal to S max times what? Reactance per phase, which is our standstill rotor reactance per phase. For maximum torque, at maximum torque, at Tmax, this is what we have. So we need this. Let us simply make it the subject. So it means, what are we going to have at the end? We simply have to divide the resistance, the standstill resistance per phase over what? Over the maximum slip. So do we have that? That is the question. The resistance per phase for these standstill values is there. We have it here. We have the value. So what is it that we do not have? The maximum slip. So with the information that we have, the maximum slip can be determined, and we need per unit slip. So we are back here, per unit slip. Remember your formulas. So we're going to take this into consideration. We need maximum slip. So for us to obtain per unit slip as a maximum value, we're going to need synchronous minus the maximum speed of the rotor over what? Over our NS. We have this because that is where the torque, maximum torque is occurring. So it is there, but NS is not given because they know that you can calculate this one. Remember your NS, 60F over what? Over P. We talked about this formula. So we're just going to substitute our frequency. That is 50 over the pair poles, which is 2. So that was going to give us 1,500. So here I'm rushing, guys, because we talked about these formulas here, 1,500 revs per minute. So we can substitute now into our formula. Our NS, 1,500 minus our maximum, 1,375 of the rotor. This is of the rotor, remember? Over 1,500, over 1,500, our NS. As per unit value, there's no need for us to calculate a percentage. We need a decimal there. So just calculate per unit. All right, so that was going to give us 0.083. So that's our per unit slip, but it's maximum. It's maximum. With this, we can determine what we need here, which is our reactance. So that was it, guys. So with this, just going to substitute. Remember, we have this value of 0.25. So that's 0.25 over our maximum slip as we calculated per unit value, 0.083. So just substitute your value. That was going to give us our reactance. So that is it. That is it. Which was going to be 3,012 in ohms per phase. That's a phase value. Per what? Per phase. Per phase. It's a standstill rotor reactance per phase. Who there? Standstill. Just like that. All right. So know your formulas, guys. All right. Just it was just a matter of manipulating the formula in that case. All right. So just in any case, we might need this value. We got 3,012. All right. Let's move on to the other part of our question now. They are saying here, B, the torque developed by the motor while running with a slip of 5%, the torque that. I want us to get here to T1, the understanding of our T1. It is not a maximum torque T1, but it is a torque that happens at a certain slip. To say when we have T1, this is supposed to be the slip affecting T1. So that is the condition. So you're simply talking about the torque that is happening at any slip, at this slip, at that given slip. So in our condition, you understanding this, it simply means that they are saying calculate the torque developed. We do not know that. So it's going to be T1, like any value. You can just use whatever number that you want. So we do not know that. But at this value, at a slip, you are given S1. At this torque, at that value, we are given the slip. So as a per unit value, just divide by what? 100. That was going to be 0.05. That is the condition. That is our condition at that value, at that slip. So on your formula, just going to take your formula as it is. As it is. So we say that our T1 is equivalent to what? So that was just a matter of substituting, guys, into our formula. The whole of our formula, that's going to be 2S1 RP 2 squared over what? We're going to have the same RP 2 squared plus, that's the same here, S1 Rx. This is X here, not R, but X. All right, so that is our condition there. So this is XP2 squared like this. All right, so remember, the whole of this part here is going to be affected by what? Our maximum slip. So that's our maximum slip here like that. So that is the condition. So understanding this, guys, you are done. Knowing that you are dealing with what? With the T1, the torque that is at any point. So you must have slip here and also S1 affecting this one. They are at that slip. All right. For our maximum torque, all right, guys, remember your Tmax here times your Tmax, your maximum torque. Do not forget. So your maximum torque, as it is always, your maximum here with its what? Maximum at these ones, these two, they go hand in hand. This one and this one. That is the condition of your question, just like that. So let's substitute, guys, direct into our formula. That was going to be equivalent to what? Do we have all these RP? It's there, this one. The slip you're already given. So this one was just a matter of substituting. Our slip is there at this T1. Our slip is what? 0.05 times at standstill. The phase value is what? 0.25. 0.25 squared over what? Same value, 0.25 squared like this, plus the slip that is at this torque, or S1, which is what? 0.05. So that's 0.05 times the reactance. Remember our reactance, we calculated this one. Like I said, you're gonna need this 3.01, okay, 3.012. So that's 3.012 squared. The whole, this bracket, the whole of it, you're supposed to square it. So remember, we opened this one, this mother bracket, this one. So let me do it this way so that we understand each other here. So remember, we had this one. So let's put it this way. It's a bracket, it's a major, the major bracket that is affecting this whole part that we have in the what? In the denominator, to say what is in the denominator is going to be affected by what? By this maximum slip that we see here. So we have to open a bracket to show that one. All right. So you're going to open a bracket like this. All right. I wanted to change this one like this and like this. Then you multiply it to the what? The slip, the maximum slip, which happens at what? At this maximum torque, this one, the maximum slip. So do we have that? We have it from the information that we had here. They said at this maximum torque, we are given maximum what? Speed. And we calculated the maximum what? The maximum slip from there. So we're going to take that value, this one that we got. All right. So that was what? 0, or maximum, this one, as a decimal, 0.083. All right. So that is it, guys. Just like that, we're going to multiply this whole part to the what? To the maximum torque, as we are saying this whole part times our maximum torque, the one that we are given. What is our maximum torque? 220. So that is 220. So that is it. You're going to simplify this, and our answer is in what? Newton meters. So you can even do this, guys, on your calculators. You can simplify this on its own, then you multiply to 220, whatever that we have. So you can even use your calculator. It's only that my calculator is fixed to 3 decimal places. So whatever that I'm going to have will be 3 decimal places. So this is what I'm trying to say. You put this 2 times, that's 0.05 times 0.25 squared over what? Since there's a mother bracket, the mother bracket here containing everything, open a bracket, all right, then write 0.25 squared plus these two, they're inside a bracket, like it's a smaller bracket. You can even open it like this, 0.05, like this, times 3.012. You close it, then you square. But remember, there's this one that we opened here previously. Let us go back, our calculator, go back here. At the starting point, there is a bracket that we opened here, this one. So we must close it at the end. This one was the opening of this bracket here, opening of this bracket here. So we must close it at the end there. We must what? We must close that bracket. So that is the idea of what our question. We must close our bracket, this one. So let's go back where we were and close that one. All right, I could have just used another way. Anyways, this is where we are here. So, okay, it skipped here, back here. After the squared like that, you're supposed to close the bracket to indicate what? You are indicating one. All right, there are two things that you are indicating. The closing of that bracket to say whatever that we had, and it is not affecting this other part that is following, because it is, remember, there's the 0.8, this one, which has to follow. So after closing the bracket, we are supposed to multiply by what? Times 0.083, like that. All right. So like I said, it's only that my calculator is what is being fixed to 3 decimal places. So you're going to have 0.884. All right. So that was going to be 0.884 like this, times what? Times the 200, which is following 220. Remember, we're simplifying this. It is best for you to simplify that part. Then whatever that you get, you multiply to this one, or you can just multiply, guys. It's on your calculator, guys. You can even just multiply on your calculator 0, whatever that we had there, everything. So now we're going to multiply to 220, which was going to give us what? 194.480. So that's it. That's our torque in that case. So it was going to be 194.48. All right. And Newton what? Newton meters. Just like that. So answer the question. Answer the question. What is that you're given at that condition? At that condition. This is the part of your maximum torque. At that value, what are you given? All right, then we move on to another part B. They want us to we are still on the calculation of what? Right, another part C, they are saying the starting torque, all right? It's on the torque there. But they're saying the starting torque of the motor, the starting. When you are starting, what is the effect? Because here, we had a condition, guys, where we are calculating torque, isn't it? Where we are calculating torque, guys. But it was developed while the slip is 5%. So what is the effect now when starting? What is the effect? Remember, the effect is on the slip. Per unit slip is 1 when starting. We talked about that. I think, okay, those were, I don't know, guys, here. Let me just go back here. Those previous notes that we had. At starting, same as what you're at standstill. The per unit slip is the one. We are back to that part again. Per unit slip is the one that was going to be affected. That was the one that was going to be affected. So in our condition, we are saying at starting, we are supposed to have, okay, I'm going to come back here to our formula. So in our condition, remember we said T1, the torque that happens at this slip. So we are starting, so we can just call it what? T start. So we are supposed to calculate what? T start, starting. So at this torque that we are saying, it means the slip that we are going to be talking about is at what? At the starting also, which is 1. Per unit slip when you're starting is what? Is 1. So that is, these two, they go hand in hand, remember. Just like the maximum slip and what? The maximum torque, they go hand in hand. So the question is, our maximum slip here affected, the one that we calculated, remember? All right, we ended up calculating that maximum slip, no problem. We have our value, all right, no problem. But we calculated, if you still remember, when we calculated that our maximum slip, which gave us 0.083. Is it going to be affected? No, it's not affected because it was from the maximum speed. So the maximum slip is still going to be the same, which is affected at what? At maximum torque. The only part that was going to change in our question was the slip at start is 1. That is the only part. So meaning to say your formula here, I was not even supposed to erase the first part. Your formula is not even affected. Your formula will be affected here to say, now we are talking about what? At starting. So you're just going to call it what? T start. So this S is no longer S1. The slip that you are having there, remember, it goes hand in hand with the torque that you have there. So it means that's our S start. It goes hand in hand with that torque. It is the one that is being affected when you are starting. Everything is remaining the same, guys, as we had. So it was going to be 2 times what? At starting. Per unit slip is what? It's 1. Our RP2 as we had, it was going to remain as it is. Resistance, remember, is not affected by what? By slip. It's not a product of what? Of frequency. So it's not affected by what? By slip. So resistance value is not affected. It's just going to as it is. So this one, again, it was going to be as it is. But here on our reactance now, remember, it's what? The slip times reactance. But the slip there is the one that is where we have at what? At starting, which is our 1. So we're going to use this one. It is the one that is affected. The maximum slip is not affected, this one. Our maximum slip is not affected together with, because we are working at what? At maximum torque. So the maximum torque also is not affected. So these were the conditions that we're going to have, which were going to affect our question. These were the conditions. The slip there on your slip. So it means our T stat was going to be what? Just like the previous case, guys, we can simplify the whole of this part, then multiply to 220, or just use your calculator, guys. Your calculator can simplify these values, guys. It's small, it's big for these things. Use it to simplify everything. That was going to give us something like 36.271 if you just use your calculator at once, 3 decimal places, just like that. What is being affected? Sleep. So do as many questions as you can using this information for calculations about the maximum torque. Whenever you are given the maximum torque, these are the conditions that you must put into consideration. Or when they want you to calculate it, you're supposed to put that into consideration. So when you are given, it means the speed that follows after that is your maximum. If they gave you the slip at that condition, they can, it's not always where you're given the speed, where you're given the value like that.